All right, so I've got my piece here in the mill. I've got my little indentations there, and what I do is I put the collet size in that allows me to put in this spring-loaded center, and I like using this method of finding the lining up the hole. So now all I got to do is let's see if I can move this down and use a magnifier. That's perfect. I'll lock my X and my Y. All right, so I drilled these holes. The whole drill size I use is pretty much spot on for the size diameter of the screw. And remember, I talked about that probably in the original casting these holes would have been a little bit larger for a little bit more of a fudge factor. So by using that size drill, I didn't allow myself any fudge factor. So I just relied on thinking that, well, maybe I would be lucky and get it spot on, and lo and behold, this one goes in perfect. This is resting on here, and this goes in, which is exactly what I wanted. But when I bolt this in position, I can't get this one to go in. In fact, I can't get this one to go in at all because this hole is actually slightly high to the hole behind it. So the only way to bring this down would be to either shave some off of the bottom here, which would then bring this hole slightly down, so then this hole wouldn't line up, or do what I should have done in the first place, which is just giving myself a little bit more of an allowance and drill these holes a little bit larger. So I'm going to leave this one, since this one's spot on, I'm going to leave this one alone, and I'm going to overbore this just a slight amount. That's it. That's all it took. That slight amount there. This screw's not going in because this is kind of it's a bad screw. Bolt, I should say. This one seems to be much better. Actually, I need to probably chase these threads with a tap. They're a little cruddy. But it's going to work. That's the important thing. All right, so far so good. Now I've got to locate the center of the hole that's going to go up here. All right, so I've got this temporarily resting on top of here just to show the relationship between this part and this part. So obviously, for this to be able to rotate from vertical to horizontal, I've got to have clearance between the bottom edge here and this top piece right here. So I know that ideally I want my distance from this point right here, say, if I use this as a reference, which is the bottom of my plate, which would make it easier. I want the distance from the bottom of this plate to the center line of this shaft to be as short as possible while still allowing clearance here for this whole thing to rotate. So what I could do is I could take a measurement from here up to the bottom of the shaft, add half the dimension of the OD of the shaft. That would give me that distance from here to the center line, and then just add a small arbitrary amount for clearance. I've got a little bit of a fudge factor, I figured, because putting this up higher is only going to change the length of the belt, and that's adjustable down at the motor anyways. So I'm not quite sure how much this was originally sitting up off of this, but I'll probably just leave like 1/8 of an inch, if that. So I took my little depth gauge here and I basically held it up against the side here and up against the side of the shaft, and I set it, and then I checked in several locations because I wanted to make sure that this shaft is actually concentric to this outer diameter right here, and it turns out it's not. Actually, when I put it on this side, there's actually a space in there. Okay, so that's actually the short. So as long as I've got the long dimension, which apparently is, whoops, I'm gonna drop that. As long as I have that long dimension, that's all I really need. All right, so now to this dimension right here, whatever this ends up being, I've got to add half the diameter of the shaft plus my clearance. All right, so now I added that dimension that I had from the depth gauge to half of the shaft diameter, which is 0.265, and to that I added 1/8 of an inch, or 125 thousandths, for clearance here. And I set my dial calipers for that, and if I just eyeball and put this on here, I can see that I got a little bit of a clearance there, which is what I want. Now I'm going to take this over to the stand, and I'm going to see whether or not there's any kind of an interference problem that I may have missed. Now, without having this all assembled, I can't know for sure exactly where everything's going to line up. But here's the platen for the or the base for the disc sander component. So obviously I can't have this hole located so low that this is going to rub, but more obtrusive than that is actually the shroud, the plastic shroud that goes behind it for sanding. Not for sanding, for allowing the hookup of a dust removal. So this right here is really my limiting factor as far as how low that can be located. Because when this is on there, I don't think this is far enough out that this is going to clear this ledge here. So I've got to take that into account. So if I rest this on here just like this, and I eyeball it, I don't think that's going to be a problem, because I think we're already, by default, we're up here, so to speak. So I think there's space there. All right, so this dimension is actually the dimension from this edge up to the center line of that hole. So if I now take this, put it on here, I can see I'm way up here. So this is going to sit up around here when this is all installed and put back together correctly. Shouldn't be a problem. Oh yeah, so I've got to actually add, so right now this dimension that I have on the caliper is the dimension from this point to the center line of the shaft, including that space in there. So I've actually got to get this dimension from right here to that top there. But I'm wondering about these bumps right here, whether or not they're going to be an issue. I'm glad I didn't go with those dimensions, because I ended up finding this plastic PVC cap. It's almost the diameter. It's just slightly under the diameter that I'm working with over there. And what I did was I marked the center. I found the center on it right there. And then I came over and I set my dial calipers to the 4.040 total dimension that I came up with. And if I go from this bottom reference point up, you can see that that's actually pretty much like almost exactly right there. So if I had done it, if this diameter perfectly matched that one, I would have pretty much zero clearance here because of these bumps. There actually is the clearance right in there that there's more than the 125 thousandths I can see right there. But I forgot to account for these bumps sticking up and the way that they impinge on this diameter. Not only that, but I just said this diameter is slightly under what I actually have for a diameter over there. So I need to take into account more clearance to raise this up so it clears these bumps, and also the fact that this is just a tiny bit smaller. So I'm going to have to bring that up. Well, let's see if we can't figure out how far we got to bring it up. All right, so I went back and I looked at the calculations I made, and I had originally factored in 125 thousandths, or an eighth of an inch clearance there, and that wasn't enough. So then I thought, well, maybe I'll just double that and go to a quarter inch. I added another 125 thousandths, and even then I was kind of still a little worried there. So I just went to 3/8 of an inch, and I got it now set that if I go with 3/8 of an inch, if I put my mock up in here and I line it up at the bottom there, you can see there's a pretty decent sized space in there. Now about 65 thousandths of that is going to be taken up by the fact that that diameter I'm dealing with is diameter is a little bit it's about 130 thousandths larger than this mock-up I have here. All right, so if I wanted to get really fancy and finicky about it, I could actually I could turn something in the lathe to the exact diameter, but I don't want to get too crazy. I think I'm already kind of over explaining what I'm doing here. So my temptation now is to just scribe a circle using this as a guide, but the problem is that I'm not going to get a true circle because of the fact that this is tilted down. So if I hold this up, if I line this up where it's supposed to be and then hold it vertical and then I try and do it, I've got another problem where I've got to really keep this vertical, so I'm going to have a little bit of trouble scribing this doing that. So if only I had like a precision gauge pin that would fit perfectly in there. Well, voila. This can of Napa glass cleaner is the perfect diameter for that hole, oddly enough. So if I take that now, I keep this in position, get this out of the way. Voila. I'm going to go back to that center point. Left to right should still be pretty good, but top to bottom. So I want to move this line up to where it should be. So what I want to do is I want to find the center of this circle. And the easiest way to find the center of a circle that I can think of in this kind of a situation is to put it in a box. So I'm going to put a line that is tangent to the circle at this point here, and then I'm going to run another line that is parallel to that line that is tangent to the circle at this point at the top. Then I'm going to drop a line perpendicular to these other two lines, but is tangent to the circle on this side, and a line that is perpendicular to the circle, to the other two lines and tangent here. Okay, now I've got a box around that circle. Now if I draw a diagonal line from this corner to this corner and this corner to this corner, where those two lines intersect is your circle's center. So here's my line, and there's my center. I wasn't far off at all. I probably could have left this alone. I'm just a little bit to the well, actually I'm going to go with my center line here. I'm going to bring this over to here. So that's going to be my point. So let me get a center punch. I like it. All right, so what do I need next? Well, I actually need a couple of things. I need a hole in the middle for this shaft to come out through. And then the other thing I need is I need holes where these 2 points are right here, but they can't be just regular holes. They've actually got to be slotted holes. And they got to be slotted holes that actually follow the curvature of this circumference right here. So now's a good time to talk about order of operation. So now that I got my center punch mark, it'd be real easy for me to just plow a hole right through there and put that hole in the middle. The problem is then when I go back later to put in my slotted holes, I'm going to have some difficulty there because I'm going to be wanting to determine the arc of these slotted holes by the center point here, which will be pretty much non-existent because there'll just be a hole here. Follow my drift. So what I'd like to do is I'd like to try and preserve that, and since in order to make my end mill follow an arc, what I'm going to do is I'm going to end up using a rotary table. So if I position my piece here on the rotary table, and if I get this center point right here perfectly aligned with the central axis of the rotary table, I can then actually have an end mill sitting out here at the proper predetermined distance, and when I rotate my rotary table, it will actually plow out a slot, and that slot will follow the circumference of the circle. And that's exactly what I want to do. So I want to basically tie this point right here to this center point on my table. So the easiest way I could think of to do that would be to actually have a piece in here that sits right down inside here and has either a pin or a hole for a pin that I could then drill a hole here corresponding it, and then basically it would sit on that pin. Then I can clamp this down to the table using the slots. Of course, the other thing I'm going to want to do is I'm going to raise this up and put some scraps underneath there to raise it up enough so that my end mill doesn't damage the table, because those slots have to go all the way through. Oh, nice.